In this lesson, we will be having a look at exponential equations. So exponential equations contain a pronumeral within the index or indices of the terms in the equation. So for example, 2 to the power of x equals 8. Can you see that x is a pronumeral and it is a power or index? So that is an exponential equation. A simple exponential equation is in the form a to the power of x equals b, where a is greater than 0, b is greater than 0, and a is not equal to 1. So when we are solving exponential equations, there is only one solution. And many exponential equations can be solved by expressing both sides of the equation using the same base. So for example, here we've got a to the power of x equals a to the power of y. That means that x will be equal to y if the bases are the same. Let's have a look at some examples. So in these examples, we need to solve for x. The first one is 4 to the power of x equals 16. So what we need to do is we need to get the both bases the same. So I'm going to leave 4 to the power of x as is, and then I'm going to change the 16 into 4 to the power of 2. Now that the bases are the same, I can say that x is equal to 2. Okay? And then you can always go back and check, is 4 to the power of 2 16? If it is, then your answer is correct. Question 2. 2 to the power of x equals 1 over 16. We're going to leave 2 to the power of x as is, and then what I'm going to do is I'm going to change the 16 into 2 to the power of 4. So 2 to the power of x is equal to, you know that 1 over 2 to the power of 4 can be written as 2 to the power of negative 4. Now the two bases are the same, they are both 2. Therefore, I can say that the indices are the same. So x is equal to negative 4. And that's your answer. In part 3, we've got 36 to the power of x equals 216. Now, what we're going to do is we're going to simplify both bases. Okay? So the 36 I'm going to write as 6 to the power of 2 and to the power of x. Okay? Because 6 to the power of 2 is 36. I can also write 216 as 6 to the power of 3. So you always need to aim to have the same bases. If I expand the brackets here, I get 6 to the power of 2x, because we multiply the powers, equals 6 to the power of 3. Now that the base is the same, therefore I can say that 2x equals 3. And if I divide both sides by 2, so that the 2's cross out, I find that x is equal to 3 over 2. So sometimes your answers can be whole numbers, negatives, or even fractions. More examples here. Number 4, we've got 5 to the power of negative x equals 125. Well, I can't simplify 5 any further, isn't it? So I'm going to leave it as 5 to the power of negative x. 125 can be written as 5 to the power of 3. Now that the two bases are the same, I can say that negative x is equal to 3. The powers are the same. I can't leave the unknown as negative, so what I'm going to do is I'm going to divide both sides by negative 1, so that the negatives cross out, and we end up with x equals 3 times divided by negative 1 is negative 3, and so x is negative 3. What that means is, if I had to go back and check my answer, is 5 to the power of negative 3, 125. Well, that would be equal to 5 to the power of 3, which is in fact equal to 125. So you know that your answer is correct. Part 5, we've got 27 to the power of 2x plus 3 equals 9 to the power of x. So 27, as you know, you can write as 3 to the power of 3. And that is all to the power of 2x plus 3. The 9 we can write as 3 to the power of 2, all to the power of x. Okay, so now we've got the same basis. That's great. What we need to do is first, though, get rid of the brackets. So I'm going to expand the bracket here. So 3 times 2x will give me 6x, and 3 times 3 is 9. So make sure you multiply both terms by the 3 in here. And then it is equal to 3 to the power of 2 times x, 2x. Now that both bases are the same, therefore I can conclude that 6x plus 9 is equal to 2x. And here we've got an algebraic equation to solve. So what we're going to do is subtract 2x both sides, so we collect like terms. So we're going to end up with 4x plus 9 equals 0. Then we subtract 9 both sides. That crosses out, so we are left with 4x equals negative 9. And then divide both sides by 4. So they cross out, and x is negative 9 over 4. You can leave it as a fraction. And that's your answer. Last question here. 7 to the power of x is equal to the cube root of 49. So let's leave 7 to the power of x as is, but then I'm going to write the 49 to the power of 1/3, because as you know, 1/3 means the same as the cube root. So then we've got 7 to the power of x equals, I'm going to change the 49 into 7 to the power of 2. Everything to the power of 1/3. I'm going to keep going with 7 to the power of x equals, we expand here power to a power, so we remove the brackets. So 7, 2 times 1/3, that is equal to 2/3. And so now that the bases are the same, then we can say that x is equal to 2/3. And that's your answer.